Good morning, children. Namaste. Successfully, we completed the three-dimensional geometry, that is the coordinate system. In that one, we discussed and we learned about the DRs, DCs, shortest distance between the two lines. Like that, so many concepts we learned and we complete the exercise also. Now we are in a different concept, that is the plane. Plane is a part of three-dimensional geometry. Three-dimensional geometry means so many concepts are there. It is begin with coordinates and DRs, this is already is over. The second concept is the plane. Plane is well known, it is a main branch of that subject, that chapter. It is very, very important and containing so much of weightage, even in the concept, in the theory and objective also. So it is very important. We have to learn it well. Okay, now? Yeah, the plane. The plane, first of all, for the plane there is no definition. You may feel that how a mathematical term not having the definition. Yeah. In the geometry means the chapter geometry, the mathematics geometry, the branch of mathematics geometry is everything is our assumption, our imagination. Is it not? By imagination, we can construct a diagram. Through that one, we can solve the problems. Okay, now? Yeah. So, here in this geometry, the plane, some fundamental concepts are there. Fundamental concepts. Already I mentioned the fundamental concepts of geometry. Three-dimensional geometry, two-dimensional geometry, whatever it may be. Those are the point, the straight line and the plane. These three are not having the perfect definitions. Okay, now? Mathematicians consider these three. They decide the three concepts are a very fundamental concept. Fundamental concepts means there is no definition. We may give somewhat it is a definition for the point, for the straight line, for the plane. But mathematically it is not possible. Okay, now? Already we discussed in the first year the point and the straight line. You see, if you want, once again we recall, if you want to define the point, means it is a common spot, a common place. It is a common to the two straight lines. Is it not it? Then it is a point. So that means if you define the point, it means we need already the straight line. If we have some idea about the straight line, then we can say it is a common place, it is a common spot, it is a common to the two straight lines. Is called the point. But it is meaningless. The very, very fundamental, very starting concept is the point. You see, so without straight line, point is not be defined. Similarly, what is a straight line? Straight line is a sum of or a set of points. Is it not it? Set of points. You see, if you define the straight line, we need a point. Already we have some idea about point. If we define the point, we have already the concept of straight line. They are interlinked. So it is not correctly defined the point and straight line. Not possible. One is connected with another one. That is why the mathematicians decided that these three are fundamental. You see here how the plane is connected for these two means. If you want to draw, if you want to tell, if you want to express or explain the point or straight line, we need a plane. Isn't that it? All these things are all on the blackboard, on the board itself. That means we need a plane. So the plane, the point and straight line, three are connected with each other. So mathematicians they decide that they are fundamental concepts. Moreover, if anyone asks you, anybody asks you that what is a plane, we may explain for some extent. The plane, a straight line generates, you see, it is a new term, generates. It generates about a point on it. Then a plane, it forms a plane and its general form is this one. You see that? A straight line is there. For example, a stick is there. A stick. We take one stick. In the middle or at any point, if you hold that stick and you rotate, you generate. Rotate means you generate. If you generate it speedily, that straight line, that stick, some length, say 3 feet, like that. If you generate it, a fog will be formed. Wherever you see that stick will be there at one place. Isn't that? It covers some area. Wherever you see that stick appears. In such a way, if you rotate, if you generate speedily, then an area that covered by the stick, okay, na? By rotating, by generating the straight line or the stick about a point where we hold that stick. Is it okay? Na? Then that area covered by the stick is a plane. So, plane, the mathematicians decided that for some extent we may explain this one for the understanding purpose. A plane that can be formed by a straight line by generating it about a point on it. Okay, Nana? A straight line generates about a point on it that forms a plane, and its general form is ax plus by plus cz plus d is equal to 0. Okay, Nana? Like that we may explain. Okay, Nana? Yeah. Fast. Okay. We know about the plane. Of course, mathematicians decided that there is no definition for plane. But we may explain it by understanding purpose. We can define it as if a straight line rotates about a point, generates about a point, then a plane can be formed. Okay, now? Yeah. Now, what is a plane? We can understand. We can imagine. But mathematically, by some equation, we have to mention a plane. That is important. Okay, see, the very first theorem. Here, the theorems are very important. Theorems with the proofs. The first theorem. The first degree equation in x, y and z represents a plane. First degree equation. X power 1, y power 1, z power 1 is the first degree equation. Is it not it? In x, y and z, it represents a plane. It represents a plane. The equation of plane is ax plus by plus cz plus d is equal to 0. This is the general form of plane. We have to prove. You see, here this is the, by geometry, by algebra, it is a first degree equation because it is having the index 1, 1, 1. So first degree equation in x, y, z. Now you see, carefully observe it. Let the first degree equation is or b ax plus by plus cz plus d is equal to, where a, b, c, d are constants, numbers. 2x plus 3y plus 5z is equal to 8, like that. These are the numbers, coefficients, numbers. This is the first degree equation. I am taking first degree equation. In the mathematics, you see that you take any mathematical equation, no doubt it represents a curve. Already we discussed it in the first year. But without your knowledge, you write vague any question, any equation. Suppose 5x minus 7 is equal to 0. That is x is equal to 7 by 5. It is at a distance on x-axis parallel to y-axis. Is a line. Suppose x square plus y plus 8 is equal to 0. Is a parabola. Or x square plus y square minus 8x is equal to 0. Is a circle. Or x square by 3 minus y square by 7 is equal to 1 is a hyperbola. Like that, whatever it may be, not only x square, x terms, xy terms, you take any logarithmic expressions, is a curve, log curve is there, exponential curve is there, sin x plus 2, sin x, okay na? Sin x curve is there, cos x curve is there, tan x curve is there, inverse curve is there. So, in the mathematics, any equation, mathematically, if it is there, no doubt it represents a straight line. Okay na? So, here also, not straight line, it represents a curve. Here also, this is a first degree equation. No doubt it represents some curve or some geometrically, some figure is represented by this one. That is the geometrical concept. Any equation. So, no doubt it is one locus. It is called as locus. Locus means it is some geometrical diagram. We assume. Here our duty, our problem is this represents that geometrical diagram plane. Okay, na? That is the thing. You see, let A x1, y1, z1, B x2, y2, z2, B taken on, we say it is 1, on 1. We say that the first degree equation, let it be equation 1. These 2 points I am taking on that one. Just we are assuming. So that means it satisfies the equation. That implies ax1, by1, cz1 plus d is equal to 0. And ax2, by2, cz2 plus d is equal to 0. Okay na? If A lies on this one, we are assuming let A lies on that one. So it is satisfied. For x, y, z, x1, y1, z1 will come. If B also on that one means x2, y2, z2 will come. So this equation 1 and this equation 2. So this equation 2, this equation 3, already one is there. We are assuming this is 2 and that is 3. Very simple. The first degree equation, let it be equation 1. On that equation, on that curve, it is a curve, we assume. A and B are 2 points. So if the 2 points are there on that one, it satisfies. So 2 equations will be obtained. That is 2 and 3. Yeah, okay. Now we see lambda into 3 plus 1 into 2 by lambda plus 1 implies. I am taking the third equation is multiplied by lambda plus the second equation multiplied 1 by divided with lambda plus 1. What will be happened? It is a lambda x2, b lambda y2, c lambda z2 plus d lambda plus 1 into 2 same. It is x1 plus I am writing here by1 plus c z1 plus d totally by lambda plus 1. Okay now, it is not equation. I am taking one expression that implies you see that. Slowly try to understand. It is a is common here and here. So a of lambda x2 plus x1 by lambda plus 1 lambda by plus 1 is in denominator. Next b is common. Where b is common? Here and here. So b of lambda y2 plus y1 by lambda plus 1 plus c of lambda z2 plus z1 by lambda plus 1 plus d of then d here d lambda plus lambda by lambda plus 1 d of lambda plus 1 by lambda plus 1 it cancels. Okay na? Is equal to totally this 0 is there because these are the equation. LHS, we are multiplying the equation 3 by lambda and adding the LHS multiplied by 1 of the equation 2 and divided by lambda plus 1. Is 0 plus 0 by 0 is 0. So it is 0. Okay now? Now you see, it is very clear. Lambda x2 plus x1 by lambda plus 1 b of lambda y2 plus y1 by lambda plus 1 plus c of lambda z2 plus z1 by lambda plus 1 plus d is equal to 0. You see, by taking that expression, we are considering it is with our own. We are considering. Then we get you see by observing, you see, if you observe the above equation, it is one equation is equal to 0. If you observe that one, you see there is a point C. You see, C is equal to lambda x2 plus x1 by lambda plus 1 lambda y2 plus y1 by lambda plus 1 lambda z2 plus z1 by lambda plus 1. Okay na? It lies on curve 1. Will you agree? C is a point. That point lies on this curve. So that means for x we may substitute this one. For y, by we may substitute this one. Substitute this one for z, d, same. Like that one. So by taking like this, if we consider like that, we can conclude that there is a point C. There is a point C. What is the point? There is a point, observe me. There is a point C divides AB in the ratio lambda is to 1. Observe me, clearly observe. So, whenever on, you see, clearly I will tell it. Just observe minute. Suppose there are 2 points AB, not line, just you assume. On this line segment AB, because A and B are 2 different points, I am taking on that locus. On that AB line segment, a C point is there. It is x1, y1, z1. It is x2, y2, z2. C point, we know it. This is C point. Isn't that it? It is dividing AB in the ratio lambda is to 1. Okay, na? So C point is moving for different values of lambda. Lambda is 1, that is 1 is to 1 means midpoint. Lambda is 2, it is in the trisection point. Lambda is 3, 4, 5, minus 6, like that. It is moving on the line. Okay, na? It is moving on the line of AB. Okay, na? Please try to understand. If A and B are 2 points on that locus, on that some geometrical diagram, if A and B are 2 points, then on that line, automatically a C point is there. For different values of lambda, it covers. So, a line is there. Suppose B point is like this, then also it covers the line. Suppose B point, AB point are like that, it covers. It covers. So, at last we can conclude that everywhere that C point is there for different values of lambda. Okay, na? So, it covers a plane. That means a line AB is rotated like this. It is rotated. Okay, na? So, everywhere the C point is there. If AB is there, total on the line C point is there. If AB is there, total on the line AB, C point is there. So, total it covers. It forms an area, a region. Okay, na? That is called as a plane. Is it that? That means here the locus, simply you try to understand. Locus term is value term. The locus is the locus 1 is the plane. We can conclude that the plane. Okay, Nana? Hence, it is the equation of plane in general form. Hence, the general form of plane is AX BY CZ plus D is equal to 0. Okay, Nana? But this proof is not needed. Don't learn it, don't by heart. But some idea, the first degree equation represents a straight line. I mean a plane. Okay, na? You see in the geometry, first year geometry, AX plus BY without this CZ is a straight line. If that CZ is there, that straight line generates, so that we can get a plane. Like that also, you can understand, you can remember that one. Okay, na? The general equation of plane is AX plus BY plus CZ plus D is equal to 0, which is the first degree equation, which is the general form of plane. Okay, na? Like that. Yeah.